Greetings, amazing students. All right, guys. So in the last video, we learned about quadratics and their properties. One of the big properties we learned last class was the zeros. What are zeros? X-intercepts. And what we're going to do now is talk about how zeros relate to factors when we factored diamond method, AC splitting method. Remember to take notes. Remember, Mr. Park is available if you have any questions. All right. So, when we're solving quadratic equations, we're looking for the solution. When looking for a solution, that is talking about the zeros, roots, or x-intercepts. It can be asked 4 different ways. So in your notes, I would pause the video and have solution, zeros, roots, x-intercepts. All of these are synonyms for the same thing. So what does a graph look like that has 2 zeros? What does a quadratic graph look like that would have 2 zeros? Well, it could look something like this. Why does that have 2 zeros or 2 solutions? Because it's passing through the x-intercept, right, twice. What would a quadratic look like that had 1 zero? Pause the video, think about it. What would a quadratic look like that only had 1 zero? It would look like where it would only hit the graph 1 time, right? Something like that. Or it can even be facing upward, concave up, right? It only hits it 1 time. This is actually also called a double root. And I hope you're sketching a graph in your notebook and having 2 zeros, 1 zero, no zeros. So what would a graph look like that had no zeros? No solutions, no roots, no x-intercepts. Well, it wouldn't touch the graph at all, right? It could be facing down as well. So here's some examples. So let's talk about how do my factors relate to my zeros. So if I told you to factor this, x squared minus 5x minus 6, right, you would put negative 5 up here, negative 6 down here, and you want to know what add to get negative 5, but multiply to get negative 6, and that would give you negative 6 and positive 1, right, and give you the 2 factors of x minus 6, x plus 1, and this is just y equals this. This is the equation. This is me breaking this down into its factors. But what does that mean? X minus 6, x plus 1. Well, let's look at the graph. How many zeros do you see? How many roots? How many solutions? You see 2 of them, right? You see 1 here at 6. And you see 1 here at negative 1. Let me go back. My 2 factors were x minus 6, x plus 1. My zeros to the same graph is x equals negative 1 and x equals 6. Are you noticing a relationship here? But why is that the relationship? At these points, well, let's talk about what points these are exactly, right? This is 6, 0. This is negative 1, 0. What do you notice about both the y values? Any point on the x-axis, the y value is 0. So if I know that my equation was y equals x squared minus 5x minus 6, and if I know that my 2 factors breaking that down gave me y equals x minus 6 and x plus 1, if I wanted to find the zeros or the solutions or the roots or the x-intercepts, and I know that the y value should be 0 at that point, where would I plug a 0 in my equation? For the y value, right? If you don't get that, let me repeat it one more time. If I was looking for the zeros or the x-intercepts to my equation, to my graph, and I know that any place on the x-axis the y value is 0, where would I plug in 0 to my equation? Into the y value. Well, let's break this down. If I know 0 equals x minus 6 and x plus 1, I can set both of my factors equal to 0. I can set both of my factors equal to 0 so I can solve for the x-intercept. How would I solve? Let's start with this first one. 0 equals x minus 6. If I wanted to solve for x, how would I get rid of the minus 6? I would add 6 to both sides. That's right. So that would give me 6 equals x. Well, there's that y-intercept right there. I mean, that x-intercept right there. If I was to solve this one, 0 equals x plus 1, how would I get rid of this plus 1 to solve for x? Subtract 1 from both sides, giving me negative 1 equals x. Well, there's that 0 right there. Are we seeing the connection? Okay, and this is just me saying that again, okay, relating the factors to its zeros. Okay, always remember, you can pause the video, you can rewind, you can re-listen to what I say, right? I'm not there to answer your question in person, but maybe reviewing what I said might make the connection. Let's try another one. I want to figure out the factors of 2x squared minus 2x minus 12. Okay, we can use the AC splitting method, right? We would multiply A times C, so the product of negative 24, the sum of negative 2. So I'm trying to figure out what two numbers would multiply to give me negative 24, but add to get me negative 2. So I know the bigger number would be the negative. All right, and that would be 4 and negative 6. So if I had 2x squared minus 2x minus 12, I'm going to be split the middle term. All right, this is all review at this point, so you should be able to follow along with me. Group them together, right? That would give me 2x, x plus 2, and this would give me negative 6, x plus 2. All right, so my two factors would be 2x minus 6 and x plus 2. So here's my two factors. So what do I do with my two factors to find the solution or the roots or the x-intercept or the zeros? What do I do with my two factors? I know that at the x-axis, wherever this is going to cross, the y value is 0 here. So I'm going to set them equal to 0. So 0 equals 2x minus 6, x plus 2. 2x minus 6 equals 0. X plus 2 equals 0. Solve. Okay, pause the video. Solve. So add 6 to both sides. Divide by 2. X equals 3. Subtract 2 from both sides. X equals negative 2. So I should have an x-intercept at negative 2 and an x-intercept at positive 3. And this was an upward-facing parabola. How do I know it's upward-facing? Anyone remember from last class? How do I know this is an upward-facing parabola? Because my a value is positive. I'm going to show you another option for when you're factoring that may be helpful for some of you. Now, if this confuses you, you know how to factor, okay? And that's good. Okay, but this is just something that some of you, I think, would appreciate me showing you. What are all of these divisible by? 2, 2, and 12. They're all divisible by 2, right? So technically, I could factor out of 2 here. Did you see what I did? All right, if I distributed 2, it would give me this, right? Well, isn't it easier to factor this, x squared minus x minus 6? What would add to get me -1, but multiply to get me -6, -3, and +2. So my two factors would be x minus 3, x plus 2. And if I did the same exact thing here, and set my factors equal to 0, add 3 to both sides, give me x equals +3. Oh. Subtract 2 from both sides, x equals -2. Right? So I did the same exact thing, except I factored out a 2 so I could use my x method because my a value would be 1, rather than have to use the AC splitting method. So this is just a shortcut for my factoring world. Okay? All right. So there you go. We factored it and got those zeros. So here's the thing. Can you make the connection between the factors and the zeros? My factors, I set them equal to 0 because at the x-axis, the y value is 0, and I solve for x to find my zeros. So let's look at some examples, okay? We're going to do these all by hand, all of them by hand. The total number of seats in an auditorium is modeled by f of x equals 2x squared minus 6x, where x represents the number of rows of seats. So x represents the number of rows of seats. And y represents the total number of seats. So x represents the rows, y represents the number of seats. How many rows, so I'm looking for x, are there in the auditorium if it has a total of 416 seats? What does seats represent? Y. So let's rewrite this. Y equals 2x squared minus 6x. What information did it give me? That there was 416 seats. What does seats represent? Seats represents the y value. So where am I going to plug 416 in at? For y. And what am I solving for? X. Now, on all of these problems, when you're looking for the answer to x, the solution, you don't want your y value to be any number except 0. So when you're looking for the solution in a quadratic, you want your y value to be 0. Why? Because that will give me my x values. So I need to make this where this is equal to 0, not 416. Can I just erase the 416? No. How do I get rid of it? I need to subtract 416 off of both sides, giving me 0 equals 2x squared minus 6x minus 416. Woohoo! I got this looking like what we just did, right? Where I have it equal to 0. So now I'm looking for its x-intercepts. Yes, you could graph this and just look for the x-intercepts. But you know me, I want you showing your work. So we are factoring this, setting our factors equal to 0, and solving for x. Now, some of you heard me say how you can do this on Desmos. That does not mean that you're going to just skip this and do it on Desmos. No, you are working it out. That's only how you will get credit. Okay, you need to practice the factoring. You need to see how factors are connected with your zeros. Okay, so pause the video, factor this, set them equal to 0, and solve. So hopefully you did pause the video. I'm going to factor this using what I showed you over here. Because all of these numbers are divisible by 2. So I'm going to just divide 2 out of this quadratic, giving me x squared minus 3x minus 208. So now I'm just trying to find what two numbers would add to get me negative 3, but multiply to get me negative 208. And I have no clue. So let's look at the factors of 208. So we obviously know 1 and 208. We know 2 and 104. I know my number is going to have to be pretty big. And as I'm doing this, I see 13 and 6 are also factors of 208. And I'm going to pause there because I know the difference between 13 and 16 is 3. I think I said 6. I meant 13 and 16. So if I wanted to add to be negative 3, I know the bigger number needs to be negative. So it's positive 3. Oh my gosh, positive 13 and negative 16. So my two factors would be x plus 13, x minus 16. And I need to set my two factors equal to 0 and solve. How do I get this equal to find x? I'm going to subtract 13 from both sides, give me x equals negative 13. And I'm going to add 16 to both sides here to give me x equals 16. Well, we're solving for what? How many rows are there in the auditorium? Well, can I have negative amount of rows? No. So I know my answer is the positive number, x equals 16. All right, let's try another one. What are the solutions to 2 times x minus 7 squared equals 32? Okay, well this looks a little different. Because I have parentheses, I have squared, not on the first a, it's not an ax squared plus bx plus c form, right? So it looks a little more confusing. But I can go ahead and simplify this. Now, biggest mistake most people make. Okay, let's mentally all do a check. What do you think if I wanted to simplify this down, like get rid of the parentheses and all this other stuff and get rid of 32, what's the first thing you think I would do? Most people say distribute 2 first. And when I say most, I'm definitely talking about most. But you have to remember PEMDAS, guys. When I'm simplifying, I have to follow the order of operations. So P, x minus 7, I can't do anything with that. My next thing is the E, the exponent. Not multiplying, not distributing. So x minus 7 is being squared. What does that mean? And no, that is not x squared plus 49. X minus 7 squared is x minus 7 times itself. X minus 7 times x minus 7. And how would I multiply that? Box method. So x times x, x squared. Negative 7 times x, negative 7x. Negative 7 times x, negative 7x. Negative 7 times negative 7, 49. So this x minus 7 squared actually is going to turn in 2 times x squared. What's negative 7x plus negative 7x? Minus 14x plus 49 equals 32. So we did our exponent first. Now, how would we keep simplifying this? distribute the 2. So 2x squared minus 28x plus 98 equals 32. If I'm looking for my solution, I'm looking for my zeros. And no, you cannot put this in Desmos like this. Not in test mode. So I need to, if I'm looking for my zeros, what do I know about my y value at my zeros? Any point on the x-axis, on the x-intercepts, what do you know about your y value? It is 0. So I need to set this equal to 0, not 32. So how do I get rid of the 32? Subtract 32 from both sides. So that would give me 2x squared minus 28x plus 66 equals 0. Now I can solve. Now I can factor this and solve for my x-intercepts. I'm going to do the same thing I did. You can either use the AC splitting method here, right, because the a value is 2. Or if you notice, all these numbers are divisible by 2. So I can factor out a 2. So x squared minus 14x plus 33 equals 0. So now I have a quadratic in parentheses that has a value of 1. So I'm going to use the x method instead. So I'm trying to figure out what two numbers add to get me negative 14, but multiply to get me 33. So let me list out my factors of 33. 1 and 33. Uh, 3 and 11, right? And I can stop there because those are only factors. Well, if I wanted to add to get me a negative, but it's multiplying to get me a positive, both of these numbers have to be negative because only a negative times a negative would give me a positive. So it's going to be negative 3 and negative 11. So my two factors are x minus 3, x minus 11 equals 0. Now I can set my two factors equal to 0. And I can solve. So that'll be x equals 3, x equals 11. Woohoo! And then I can graph this in Desmos to check my answer. Again, though, you are showing your whole work. You are factoring. And you are setting the factors equal to 0 to solve. Okay, I know this is a long one. Okay, last one. The function y equals x squared plus x minus 6 is graphed right here. What are the values of x when x squared plus x minus 6 equals negative 4? You have two options here. I want you to pause the video and figure out the answer. What do you think people make the biggest mistakes for this? Most people look at the graph and see, oh, 2, negative 3, there's my answer. But this says equals negative 4. That means it wants to know when the equation has a y value of negative 4. So you could look when y is negative 4, and that is at x equals 1 and x equals negative 2. Or you can do what we've been doing. I don't want it equal to negative 4. I want it equal to 0. So I'm going to add 4 to both sides, giving me x squared plus x minus 2 equals 0. I can use the x method. Why can I use the x method? Because my a value is 1. So I'm looking what it adds to get me 1, but multiplies to get me negative 2. If you said positive 1, oops. If you said negative 1 and positive 2, you are correct. So my two factors are x plus 2, x minus 1. So x plus 2, set it equal to 0. X minus 1, set it equal to 0. Minus 2, x equals negative 2. Plus 1, x equals positive 1. And there's that same answer. So you had two options here, but you had to understand what this was saying. It's saying the y value here was negative 4. So you could have looked when the graph was at negative 4. Or, like we've been doing, you don't want it equal to any number but 0, so you could have solved from there. All right, amazing students. I know this was long, but I hope you understood the connection between factors and zeros. Have a great day.